We brought the point cloud into a Revit model and sliced it up so that we could see all of the little individual parts. It would have cost us $10 million. If I had this type of information about steel when I was a framer, I would have been so many steps ahead.
Again, I'm Ellis from RCN, and I'll just be giving some very brief bios of our esteemed presenters. First up is going to be the BIM Director at CSM Group, specializing in construction delivery BIM workflows. So please give a warm welcome to Usamah Hayes and Virtual versus Reality, a Cautionary Tale.
Thanks for the warm welcome. I'm going to talk about how I've saved construction projects millions using the scan to BIM process on live construction projects in order to get early RFIs and save ourselves from change orders that are costly. I've saved a ton of money in some projects, and I'll share how I've done that with you this morning. First of all, I'll talk about how we've driven precision in construction, utilizing scan to BIM, and just making sure that every detail matches the VDC coordination process. So here we've got a laser scan that's overlaid the VDC coordination model that we put together through the VDC coordination process right there. And then how we've driven cost efficiency by utilizing that process, just making sure that everything matches. And then when things don't match, catching it early and putting it in front of the people who need to be notified of it and getting things straightened out before we get too far down the process. And then using the scan to BIM process as a really good collaboration tool in order to have everybody come to the table, look at the same thing, know what they're looking at, and drive the collaboration process forward on live construction projects. I started my career as a framer, multifamily and single family framing. Saw a lot of mistakes happen. Typically, as the framer, you run into all of the mistakes that happen: steel, concrete, MEP. Ran into it all. I then wound up prefabbing what I framed, which was a step in the process towards BIM. And then I got the opportunity to actually design what I prefabbed. And so that was my first introduction to BIM. And I just saw how it was such a useful process in order to drive cost efficiency. We were using it for estimating, grabbing our bill of materials, assembling, of course, prefabbing, and also assembling on site. And it was a really prolific process for me, going from a field guy to a BIM guy. I loved the process so much that I shared it with, I'm older now. I started in my 20s. So thousands of people at this point sharing the BIM process and the supportive platforms like Procore, Autodesk Construction Cloud, Revit, Navisworks, you name it. And then I would share that in the roles of consultant, instructor, as a designer, as a BIM coordinator, a BIM lead, BIM manager, and now as a BIM director. So my first experience with a point cloud from a laser scan was on an industrial project. We brought the point cloud into a Revit model and sliced it up so that we could see all of the little individual parts. We were working on an expansion for that industrial plant. And right then I was like, man, if I had this type of information about steel when I was a framer, I would have been, so many steps ahead of running into these mistakes on site. And so right then the juices started flowing. It's like, how can I put this into the construction process? A few years later, I had the opportunity to work as a BIM manager for an electrical contractor, and the general contractor who was running that project was actually performing laser scans. This was in one of the largest hospitals in Minneapolis, and also one of the oldest hospitals in Minneapolis. We were essentially converting a part of the underground parking garage to ER, and the ICU was above the ER where we were going to be building. And we ran into this large bank of conduits. It wasn't on the as-built drawings. Therefore, it wasn't in the existing model. Therefore, neither the architects, none of the MEP designers, the structural engineers, nobody had any idea about this bank of conduits. It was running to the ICU ward, which was a pretty large ICU ward. It was a large hospital, and the cost to basically shut down the ICU ward, move it to somewhere else in the hospital, and then pull all the cables and stuff like that out of the conduit would have cost us $10 million. We wound up, it sounds like a really simple solution now, but reconfiguring a changing room and moving some duct and cable tray in the main corridor in order to save that $10 million. So it was a really cool project that I worked on there. Next, I got to purchase my own laser scanner, and the way that I got to purchase that laser scanner was through, we were working on a high-rise luxury apartment, and it was post-tension concrete, and so we were hanging precast panels on the post-tension concrete. And every time that the first load of precast panels that showed up to the site were missing all the embeds that we needed to hang it, the precast panels. So we kind of said, well, we can't have this going on moving forward. And I basically presented how much the laser scanner would cost to the VP of construction at the time. And he said, well, we got that money sitting on site right now with the precast panel, so go ahead and buy it. So this is a 25-story building. By the time we got to the 9th story, all of the embeds started to be in the right place. And basically what was happening was the embeds weren't attached appropriately and they were falling into the concrete pour. So by the time the concrete cured, no embeds, no hang panels. So that was a really cool project that I got to work on. And that just drove the point home for me, like I need to be laser scanning on all of these live construction projects. So a little bit about the VDC coordination process in case you're not knowledgeable about it. What we do is we basically run clash detective tests with LOD 400 models from all of the trade contractors. And then what we do is we group those clashes into what we call issues or coordination issues, and any sort of coordination issue that we, the general contractor and the trades, can't solve in our own collaboration, we take that up to the architect or structural engineer or whoever the design partner is in charge of that scope, and we get a solution from them. After we get everything solved and we are able to move forward with the process, we then have the trade contractors sign off. It's really important that you have somebody from the trade contractor who actually knows how to install the scope sign off on this, because I've been through battles and stuff like that, and I have had people sign off from trade contractors who weren't installing, and then you get on site and they're like, I would never install like this. I was just like, that's why I was trying to have you sign off on it and not them, and blah, 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 right? So, and then after we get the sign off, the trade contractors install their scope per the agreed upon VDC coordination. Or do they? So, what you want to do with the VDC coordination process basically is plan with the end in mind. And for me, my customer, the end user for this process is always the trade contractor. I want to make sure that the person who I was when I was, in my 20s, who was the framer, when they show up on site, they just basically have everything set up like it's a prefab shop. And so with that, I want to make sure that their milestones are accounted for and that I give them all of the information before they hit boots on the ground on that date. And with that, I offer all of the support that I can to the trade contractor. And so here I am with one of my trade contractors. This is a cold form metal framing trade contractor, and we're looking at the model on an iPad. So the importance here is to make sure that the process goes beyond geek with a computer in an office to the hero in the field installing the scope. And so I'm showing him how he can get measurements directly from the model on his iPad, and then he can use that to make some really intelligent decisions in the field. So he basically shows up, knows where all of the MEP trades are going to penetrate his wall. He knows where all of his cuts need to be as far as getting his, studs cut and everything like that around the MEP scope. And then you want to make sure that it's not a trade versus trade environment, because sometimes when you're looking at VDC coordination then you have the trade and they, finger pointing starts to happen, blame starts to get laid. You just want to make sure that this never happens in the process, because once it starts, it basically doesn't end. The relationships get tarnished, and then you'll wind up with some bad stuff. So you want to make sure that it's a trade helping trade environment. The way to do this is to form interpersonal relationships with all the trades who are involved. Get to know them, get to know if they have kids, whatever, fishing, whatever they like to do, talk about it, and make sure that they're talking to each other and that they understand that they're all on the same team and our fight is against the schedule, right? And so a couple of other things that I do is I make sure that when forming those relationships that I give praise in front of everybody, and then constructive criticism privately. And then I also make sure that the constructive criticism is pointed at the process and not the people, right? Like, processes are broken, people are good. People are fine as long as you set them up with a process. And if you give them that understanding, then they'll want to speak out about the broken parts of my process, right? Because no process is perfect. You just continually want to refine and perfect your process, but you know that it'll never be perfect, because there's always something that you didn't account for, or at least from my experience, there's always something that I didn't. So we want to make sure that what happens in VDC actually goes out to the field. That doesn't really happen all of the time, and these errors that happen in the field can be from like a couple of $100, which is kind of what this one that I'm showing you is. Basically, the duct is in the wrong place, and therefore all of the trade scopes around the duct they had to basically conform to where the duct installed. And we discussed this. We brought this up, this exact image. We brought this up, talked about it, and the trades were like, oh, that's not a big deal, blah, 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 right? They had enough room to work around it. So a couple of $100, one trade has to move because another trade didn't install in the right place. Fine. These can grow to like millions of dollars, though, if you have part of your structural scope that's installed in the wrong place, and all of the other scopes basically follow suit, and eventually the error produces itself in a very visible way for your owner, or you'll start to see it. And like I said before, usually I would see it as the framer, like, why is this wall a foot out or whatever? And so in order to when you do that, what do, right? Do you call an audible in the field? Is that what you want to do? Or do you just drop the VDC coordination process altogether? Like, I've seen the state of both of these things happening, and neither one of them are very efficient or cost effective. So the real answer, and what I'm speaking about today, is introducing laser scanning into live construction projects, based on the same schedule that you used for VDC coordination, which is essentially the construction schedule. So when you do that, you're basically going to want to record everything. You want to record the substructure. You want to record the shell. You want to record the interior. You want to record all of the services and systems. And you also want to record the equipment and furnishings. And the reason why you want to record everything is because you never know when you're going to need anything. But if you do have something that you've been consistently recording and a problem presents itself, then you're prepared. So I like to use laser scanning like it's a seatbelt, right? I don't use a seatbelt because I expect to get into an accident. I guess nowadays you sort of can expect it. No, I use a seatbelt because if I get in an accident, I want to reduce the risk of injury. And so when I'm out there laser scanning, getting everything collected, I want to have that data available for the problem when it presents itself, because I've lived this career long enough to know that a problem will present itself, and having that data will definitely save some coin. Don't let this data turn into a tool for finger pointing though, right? Just the way that I do this is that I always remind myself that I've made mistakes in my career, and I can't recall one mistake where I woke up and I was just like, yeah, I'm gonna mess up everything today, like for everybody. Like that's never been the deal. It's always been, I was under extreme pressure. Somebody wanted this deadline to happen at this time, and I didn't have enough information to produce that deadline or that deliverable the way that it needed to be produced, or, some other factor that put me under pressure, and then I delivered something that I didn't really want to deliver. That's the position that every trade contractor is in. No trade contractor wants to install anything wrong. They want to install it right. And so remembering that, and remember, processes are broken, people are not. So don't break your people by treating them like they're broken. And then I always come to the table with the data and a solution, right? Not the solution, but a solution. And the reason why I bring a solution is because I want everybody to kind of open up and start presenting their own solutions and open it up as a brainstorming session, right? I don't even want to be right. I tell everybody on the site, like, I hope that I'm wrong, because if I'm wrong, that means that we're saving money, right? But if I'm right, that means that we got to kind of look at what we did and then make some corrections to the things that we did. And so I kind of approach it like, I'm Alfred, and the guy in the field, the contractor, they're Batman. So I can kind of walk them through, the villain and how the villain fights and everything like that. But at the end of the day, they got to go out and fight the villain. So if I even come up with a good solution, I have a couple of times, I make sure that the trade contractor gets all the credit, because they're the ones who are going to be installing it. So, and then I would say with this case study here, we had some underground pipe come in the wrong location. And if you can squint in there, maybe a little bit small, but I kind of circled around in red where the model is, and what you see is the walls are from the model, and then the pipes, they're actually from the field. And so we laser scanned it. You can see that basically the concrete is the only scope that's there aside from the plumbing scope. But clearly some of these pipes are in the wrong places. And then I put this together, and then I kind of delivered it to the design partner in the form of an RFI. And then I asked them for, forgiveness, basically, because some of their walls are obviously going to have to move, or we're going to have to break up some concrete and, move some pipes. So we had to weigh the expense and what was more risky. And so we wound up moving some of the walls and, widening them and such. And at the end of the day, for this process, the owner agreed with how we modified the design, and we were good to go. Now, this one was a little bit more tricky. I don't know if everybody here is familiar with mass timber, but it's the talk of the town for the past 4 years, and only so many people can supply it from only so many places and stuff like that. But essentially, if you've worked on a post-tension deck, it's about the same thing, right? You want to have your penetrations, your MEP penetrations in place before you start to pour the deck. So the same thing, you got to have your MEP penetrations in place before they ship the panels out to the site. From my experience, all of the penetrations are never in the right spot. Some of them are, some of them aren't the right size, yada, yada, yada. You kind of get where I'm going. So right here in this image, the purple is where the penetrations are at, and then you can see the other colorized things. That's the actual VDC coordinated model that we signed off before the panels went into fabrication. So we went out, like I said, collect your data regularly on the milestones. The CLT deck was a really important milestone. So when they showed up, we definitely laser scanned it, and then we pulled that point cloud data into the federated model, ran a clash detective test, and identified all of the penetrations that were off. And then we put this together into coordination issues and created RFIs, and then we put it on plan and this section. Now, I'm gonna stop there and say this section and this plan because I'm a 3D guy. I think in 3D, I always have, and I want everything to be in 3D. And like, truly, my personality is like, paper is a waste of time. It's a waste of resources. Plans are a waste of time. It's a waste of resources. I modeled this. It's there. I take the design partners through the model every time without fail, even though so I've worked as a BIM manager for design partners. Every time without fail, pulling them through the 3D model has failed in order to get them to grasp the context of what's going on with the VDC coordination every time. And so learning, not wanting to be insane and just keep repeating the same process and expecting a different result. My process is now put it on plan, put it on section, put it on something that they understand, deliver the information in a way that they understand. And so that's why I have this section, even though I felt like it was a waste of time when I was putting it together. I put it together and I delivered it to the design partner. The light clicked on and we started coming up with solutions. Now, in some cases, you know, the walls moved, and in some cases, the MEP trades moved their scope. And in all cases, the penetrations for the CLT deck got massaged on site. But at the end of the process, everything worked out okay. The walls got installed. The owner was pleased with the process. They were pleased with the project, and we delivered a building to the owner. And that's kind of the most important thing there, is to deliver that. What did we save though? Like, really, what did we save? Well, we saved the schedule, right? So while we were busy playing BIM Hero, the actual heroes were already installing scope that was already signed off on and well coordinated. So the people on site, like I said, they're the people that I'm delivering my deliverable to. So my work is to make sure that they keep working. They never had to stop work. So we saved the schedule, never got into a delay. We save momentum by saving the schedule, right? So whenever you have to stop something in the field, like, and I don't know how many of you, you know, once you get dialed into a process and you're like in the zone, and then like somebody comes and bugs you and it's just like, and then you got to get back in the zone. You never get back in the zone. You know what I mean? So I try to keep them in the zone, and we did that. So the momentum was never ceased. And the fact that the momentum was never ceased meant that their morale never declined. They just kept on doing what they wanted to do when they showed up on site. So we saved that. We saved labor and material. So let me just break it down to you how it could have went, right? 3 scenarios. We were in the lower level. The penetrations were from the lower level to the main level. And we could have had all of the MEP scope installed in the lower level to the penetrations. And then one of the MEP trades would have looked at an overlay and said, I don't think I'm installing in the right place. And then everybody would have either torn up their work or something more expensive than what we did would have happened. Just a little bit though, right? Or nobody noticed. They just went through the penetrations as they were, modified their scope, which is typically what happens when you don't have VDC coordination happen. And they modify their scope, and then it goes through and somebody notices on the first floor. Maybe the framer showed up on the lower level, and then the framer starts to look and is just like, oh, my wall, I can't, right? And then you have to correct it there. Worst case scenario is that you built it all the way up through the main level and the framer never caught it. And then the framer catches it on the main level after all of the penetrating systems have been installed. Now that's when it creeps into the $1 million range, right? Because now you either got to tear up a bunch of scope in order to correct it, or you have to tell the owner that this room just shrank. That's not going to be there. And so this is a country club, right? And just to point out, like, one of the like most obtuse or abrasive miscommunications that we had during the process, a floor sink for a bar, right? Floor sink is supposed to be here, but it's way over there. And then so where does the floor sink? Because the function is here where the floor sink was supposed to be, right? Do you change the function and then now you're kitty wampus, right? So those sorts of things happen. And it was just it was like a two foot by 2 foot. And typically in VDC coordination, we say an inch or greater is what we pay attention to. The other thing that we saved was the people, right? If you've ever built something and you've had to tear it apart, there's a bit of psychological damage that happens there. Now, if you build something and tear it apart and it's your fault, you have a bit of understanding. You can actually learn from the lesson, and then you can move forward with that lesson and build better, right? That's how humans are built. We learn from our mistakes. If the mistake comes from somewhere else, though, then it creates this environment where I don't trust the information now. Every time I build something, I might have to tear it apart, and stop me if you ever heard this story on a construction site. But you'd start to get the feeling like what I build is not important anyway, because I'm just going to have to tear it up. So then your quality suffers again. And that drives right back to like momentum and morale. So that's what you can save on a project there. So it's easy to kind of understand, like, with the hard costs that we saved, as well as the soft costs that we save, how you can save millions of dollars. And this was a $150 million project. So we saved millions of dollars with this process just by bringing Scan to BIM into the process. So what I say is use VDC coordination to plan your work. Make sure your work is per the VDC coordination plan, and then go out and laser scan so that you can verify that the work was installed in time or in place that it was supposed to be installed. I've used this process and I've saved my projects tens of millions of dollars throughout my career. And I'm sharing this with you also, that you have some, inference of how the laser scanning process, the scan to BIM process, can be enacted on live projects and save money. So, well, thank you very much.